now. So okay. So basically your Java assignment to write is to write a program on to find the roots of a quadratic equation. And then to solve that kind of problem, you actually need to know what you're dealing with. Take away the Java for a moment and let's just look at what the quadratic equation is. A quadratic equation is an equation that expects you to find two roots or two answers, right? If it's x, we need to get an x1 and an x2. If it's x and y, we need to find the value of x and find the value of y in the quadratic equation, right? And then there are three possible outcomes of a quadratic equation on a general sense. Either your first root is same with your second root, that is x1 is equal to x2. Both of them may have the value of 5 or 15, or your x1 is 2 and your x2 is 18, like they are two different values, or your roots, your x's are complex roots. And I'm going to explain what I mean by complex roots in the sense that they have a negative square root in them. So before you start writing your Java program, you actually need to understand these key things first of all. So that's the algorithm of it. They also need to understand the nature Java of your Java code of your quadratic equation. The nature of your quadratic equation is such that we have ax squared plus bx plus c is equal to 0. Let me see if I have a whiteboard here. Is there a whiteboard here? Uh, Okay, so the nature of your this thing is that so that we have there's a whiteboard here, a board. Okay. It's such that you have ax squared plus bx plus c is equal to 0. That's how your um quadratic equation is. So it can come in the form of 2x squared plus 3x plus 15 is equal to 0, or it can come in the form of 6x squared plus 3x plus 8 is equal to 0. So whichever way it can come, and then you're able given to solve it. So let's say for example you're given ax squared. We don't know what our a is, we don't know what our b is, we don't know what our c is. It's basically ax squared plus bx plus c. We are basically going to figure out what the value of A is, what the value of B is, what the value of C is for us to even start solving. So in your Java program, what should come to your mind is that you're going to be asking the person, because they did not give you the equation you're solving. They just told you to write a Java program that can solve a quadratic equation, right? So so you're basically going to ask them using your Java program, okay, what's the value of A? Is A, what's A? So they can just say A is 2 or A is 7 or A is 6. You then ask them, okay, I've gotten the value of A. What's the value of B? They tell you. What's the value of C? They tell you. So then it can boil down to something like 6x squared plus 3x plus 15, right? From those values that you ask them to form the quadratic equation. Now, when they then tell you this value, we are going to be using almighty formula to solve this, and that's your minus b plus plus or minus square root of hope you can see my screen. Sharing your screen will close the whiteboard for everyone. Do you want to continue? Okay, cancel. Minus b plus or minus square root of b square minus 4 AC AC all over 2 all over 2a, right? Okay. So we will not be using this formula to solve this thing. We are going to be using this formula right inside our Java program. So remember, there are three outcomes. It's either this is actually x is equal to this right, minus b plus minus. Either x1 is either x1 is equal to x2, like we get the same value for x, or our x1 is different x2 is different. I'm just laying this foundation to be using it in the code, and or is either our x are complex number. That is, complex numbers are basically numbers that have negative square root. So they are denoted as if you did your maths 102 well, which I believe you guys did well, so well, and I even flying colors to be in every year. So these are the three possible from this complex roots. So now, how do we know when it is this? How do we know when it's this? How do we know when it's this? It will be from the output of, it's just here that we're using to find out what kind of roots our Java, our quadratic equation is going to give, right? If the value of B and they give you value of A and they give you a value of C, if you input it and everything here turn to square root of 0. If you input it and then b squared minus 4ac gives you something square root of 0, that means we'll be left with minus b all over 2a, which means our x is just this. We don't have any value of x. We don't have plus or minus. The minus is irrelevant here since our square root have already gotten 0. If our square root is not 0, if we have a square root of something like 15, that means you are going to have to have x1 and we'll have 2. If we then have a square root inside the square root is less than 0, then be, let's say, minus 10. Square root of minus 10. It will then be a complex root. So I'm laying this basis now. I'm going to dive right into our code now. I've already prepared the code. We'll be using the same code that we just finished using. So let me share my screen and this whiteboard block. Jesus Christ. Were you guys not seeing my whiteboard? Were you guys seeing my board?
Yes.
Okay. Thank
yes,
you.
yes.
Okay. So I want to share my screen now. So I'm going to go to my Java code in a GV. Okay. So this is my Java code. This is my Java code. I've already explained how to prepare the Java code. When you open your IDE, your NetBeans IDE, you click on File, or click on File, you see New Project. Wait, sorry. You click on File, you see New Project. Click on New Project. It's going to do creating new project, initializing, blah blah, tracking repository. You click next. You click next. Then you can give it a name, project name, workshop, workshop 2, no space, then you finish. So it creates a blank Java page. So it's in the process of creating a blank Java space. Okay, so this what it creates for us. Let me bring this down here. Okay. So this is what it creates for us. But then don't be scared. These things here. Most of these things are actually comments. We can actually remove them. And this is what our typical Java structure looks like. So it gives us a program that is also displaying an output hello.world. So right, these are packages basically showing because we are using system. Remember, you can run Java on your phone using Replit or an offline IDE, right? Okay. So now We have our public class working two workshop, the name of the project. Then we have our method, our main method, public static void main string args. Then underneath open parenthesis under the system.out.println. And this system.out.println is a output function, which allows it like to give outputs, right? It's just like in Python when you say print and then open bracket and you write something inside what's the quotation marks, right? So it's printing hello world out. So our Java program now is to find out the roots. We are not just printing things out, but we are to calculate the roots of the quadratic equation. So I've already written the code to save the stress. Soon will log us out in not much time, about 40 minutes or so, less than 40 minutes. So this is actually the code I used earlier on for you guys. So we are actually don't too reason the code. I'm going to explain each line of for you guys, okay? So we're actually writing a program. The nature of our program is that we'll be asking our people to give us the value of A, to give us the value of B, and to give us the value of C in the quadratic equation. Remember, they did not tell you a definite quadratic equation that you'll be solving. They just told you a program that can find the root of a quadratic equation. So there are many possibilities of value of A, B, C. So for you to like write a program that asks people to input the value of A, B, and C, we import something called scanner, which is a class in Java. We import it using this syntax. Import it using this syntax, import java.util.scanner. So this like brings scanner into your code, but it does not instantiate it. You can't use it just like that. So under this public static void, this is where your Java program starts running. Things under this starts running. This is where it starts running. So we've called this scanner class now, but for us to use it, we have to like instantiate it. We have to like create an object of the class, right? So for us to create an object of the class, we'll see the, let me rewrite the code again. We say scanner, then we see the name of the new scanner that we want to use. What's the name of the scanner? Let me, I'm seeing Vic as someone's name here. Let me use Vic. Let's say our scanner name is Vic. Vic is equal to new scanner system in. We're going to be taking in things from the system, right? Don't worry, it's underlined somehow in the meanwhile, okay? So we'll be scraping out this Vitalis. I used Vitalis, that was one of the attendants in the earlier on meeting. So I'll be removing Vitalis now and I'll be using Vic, right? Okay. So this one now, don't worry about this thing that are showing red. We'll be correcting them as we go down. So now we've created an instance of our scanner class. The next thing now is to now tell the users, okay, tell us the value of A in the quadratic equation, tell us the value of B in the quadratic equation, tell us the value of C in the quadratic equation. So to display a message telling them enter the value of A, we do system.out.print enter the coefficients of A. That's here. Then to capture and store the coefficient of A, we will declare a variable A, and we will see that we'll call the variable type to be a double, in the sense that it would accommodate a large range of decimal numbers, right? So the syntax is the data type, the variable name is equal to your scanner instance that you created dot next we are using then double our data type double, we are using double. So the scanner instance you created here is Vic. So we turn this Vitalis into Vic dot next dot double. Then we move on and do enter the coefficient of B, turn Vitalis into Vic. Enter the coefficient of C, we turn Vitalis into Vic. Then Then we've told the user to give us the value of ABC. We've succeeded in doing it, in getting their inputs. That's this part. We've captured the input and we solved them under A, B, and C, these as doubles. Now, the next thing is for us to now do our calculation from our almighty formula to find the discriminants. Discriminants, which is basically the thing inside the square root of your almighty formula from the board that I drew earlier on. So the thing inside the square root is b square minus 4ac. So now we'll be calculating this thing from the outcome of this discriminant or the thing inside the square root. So we created double data type, we created inside root. Okay, so let me continue sharing my screen. Okay, okay. So now from this calculating the discriminants or the value inside the square root of the almighty formula, we then see that if the value inside our square root gives us 0, that means we'll have square root of 0. In total, we'll now have our x will be equal to minus b plus or minus square root of 0 over 2a. That's if the value gives us 0. You now find out that your x is equal to minus b over 2a because of the plus or minus square root of 0 is actually 0. So that's how you then know that, okay, if the value inside the square gives us 0, that means we're only going to have one root. If the value gives us something greater than 0, then we are going to have two different roots. And then if the value gives us something less than 0, we are going to have complex roots, complex numbers as our root, or complex number as our root. So we started with when we have two different roots. That's if the value inside, that's if this calculation gives us something greater than 0. So we then say if we open an if else conditional statement, if the value is greater than 0, if the value, this is syntax for if condition, then we open our parentheses, then we create a variable named x1. I'll say x1 is equal to, calculate for x1 since there will be 2x when the value is greater than 0. Then we create another variable s2. Give them a data type of double so that they can accommodate a large range of decimal numbers. So x is equal to b square minus math dot square root. So this code runs to give us two roots. Then we display our display a message saying we have two roots, or you can say there are two roots to the equation. The equation have the equation has two roots. This is the first display message. Then the second display message, system.out.ln is a display function, right? To print out, just like in your Python, you have your prints as the display function. So system.out.println, the root is open brackets, root is in quotes, then you have plus x1, which is the variable here. Then the second one, we have to remember, so we say root 2 is plus x2, which is this value here. That's the outcome of this. Remember, the outcome of this will be stored inside of this as a double. Then it will display it here. So if it calculates this, and then the inside root, this variable, and then this variable here is not greater than 0 if it's now equal to 0 here. Else, if inside root is equal to 0, we only have one possibility. That means this whole thing is 0. That means we'll be creating a variable called x, because there's only one value of x, and we then say is minus b all over 2a. Remember, the b square minus 4ac has turned to 0. That's if it's equal to 0. We then only have this equation, and we just calculate it straight up. So we then say system dot out x1 is same with x2. Then we then say system dot out the root is then plus x plus this x here. Then we then say else if none of these conditions satisfy, that means it actually means that the discriminant or the inside root is less than 0, and that will give us a complex number. That will give us a complex root as a complex number. So the your Java assignment is not basically a test of your mathematical knowledge. It's a test of how you can play around with algorithms and solving problems using Java, right? So you can just come here and say else system dot out. There is the root of this equation is complex. Um, is complex, or you can just say the equation has complex roots. The equation has complex roots. So, sorry, I manipulated something earlier. Okay. Uh, so, okay. The equation has complex roots. Then you close um your conditional statement blocks. Then at the end, you then remember you imported the scanner instance as Vic. So here we are using Vitalis. Remember, I'm still using the earlier people, the code I used for the earlier people. So let's change this to Vic. And then we've soon seen that the red line has gone out. So let's now be sure to close all your parentheses. Let's now run this here. Let's now run our program. Let's now run our program. Okay, so if our program is already running, they say enter coefficient of A, like we asked it to ask us. So let's say A is 2. Let's say B is 95, and let's say C is 7. We have two roots for the equation. The equation has two roots. This is in that block where we said if the inside root is greater than 0, we said we give it a system dot out of println the equation has two roots. Then the root 1, we gave it root 1, root 2, which is x2, we gave it this. So let's now run it and try when it is equal to 0, when that discriminant will be equal to 0, when they have just one root as x1 and x2. So I think that would work if, yes, how you know what to put in there is if b square minus 4ac would give you 0, then you can actually get a 1 root 1. So let's say your a is 1 and your c is 1. 4 times 1 is 1 times 1 is 1. So you've gotten 4 on the right hand side. If you're getting me, made by b square minus 4ac, the inside root of the discriminant that we are working with. Then we have to get b squared to be 4. So it will be 4 minus 4 is 0. So that's a quick hack. So let's use b to be 2, a to be 1, and c to be 1. A is 1. Enter coefficient of a 1. Enter coefficient of b is 2. Enter coefficient of c is 1. So we have just 1 root. Here we have x1 same as x2. The root is minus 1.0. It's showing minus 1.0 because we are mostly using double, right? Yeah. So if you're using an int data type, it won't do points. It just give us the whole number part. So let's now try it when it's a complex root. Um, I think just putting um, let's say our A is 2, our B is 2, and our C is 2. Okay, the equation has complex roots. So this is it. So don't forget, first of all, understand the problem that you're trying to solve, then break it down, what your required inputs, then what's the calculation or computation behind it, and then what's the expected outcome. That's basically, so this is your line of code. This is your line of code. Um, if you have issues with setting up your NetBean or your any Java ID, you can also reach out. And then if you don't have a system, you can actually run Java, like I said earlier on your phone or in the previous meeting. You can run Java on your phone. You can either run it online using Replit, a mobile app, or you can get an offline Java compiler. Just go to Play Store and search Java offline Java compiler with seeds and to still work as efficient, at least for this code, as uh, as the system is running. So thanks so much, guys, and thanks for joining in today. I really appreciate you guys. Take care. Good luck with all you have ahead. Thank you. Okay.